This is the video for Mod 7, Lesson 6A, Creating the Unit Circle. The goal of the unit circle is going to be using properties of special right triangles and trigonometry to see relationships on the coordinate plane, and specifically with something called the unit circle. And so what that means is we're basically thinking of a circle that has a center at 0, 0, and a radius of 1. So we're essentially making angles, lots of different angles, using our terminal side and our initial side on this circle. Okay, so that's kind of our thing that we're thinking about. And specifically kind of thinking almost like a table of values. We're not going to write every single angle that could possibly go on this circle because it's 0 to 360. We're only going to focus on our special right triangles. So for example, if I have a 45, 45, 90, and my 30, 60, 90. All right, so I have like this 45, 45, 90, 30, 60, 90. Okay, and so when we're thinking of it, it's like we have our x value, our y value, the hypotenuse is going to act like r. And then I'm going to actually redraw a third triangle. And it's still the 30, 60, 90, but just, so kind of the 30-degree angle and the 45 are all the bottom ones. Okay, so what we're thinking about is forming these angles on the actual unit circle. So like if I have, let's say, if this was a 30-degree angle, when I make my reference angle, I would have almost like a little coordinate point right there. Same idea if I had a 45-degree angle and a 60-degree angle. So I can actually draw these little triangles in the first quadrant because they're between 0 and 90. Now these all have a radius of 1, right? So what that means is if I divide all of these by the same number to get my hypotenuse to be a 1, for my 45, 45, 90, you would see this would be 1, this would be 1 over radical 2, or if I rationalize, it'd be radical 2 over 2, and then same thing with this one. For the 60-degree angle, or I'll do the 30-degree angle because actually 30 would come first. Same thing if I divide my hypotenuse, because I want my hypotenuse to be a 1. This would be 1, this would be root 3 over 2, and 1 over 2. And that's like really what we would have for that 30-degree angle. And then same thing for the 60. If I divided all of these by the hypotenuse, you see it's almost the same as the 30, it's just in a different location. We would get something like this, right? And so what ends up happening is we end up taking this circle, and these essentially kind of create coordinate points, right? So like if I have my 30, 60, 90, you can see my 30-degree angle. I would go then, the x value would be root 3 over 2. The y would be 1 over 2. And that would be my coordinate for 30 degrees. And we'll walk through this in a moment, but just so you kind of see, the idea is I'm essentially plopping these inside the unit circle. I'm going to have a series of coordinate points, and then we're going to find that sine, cosine, and tangent connect to these coordinate points. That's why we're even doing it. All right, so what are the properties we're going to see with the unit circle? So you're going to have a radius of 1. And so what essentially happens is that the coordinate points are going to tell you cosine and sine. So your x value is going to end up being what the cosine of that angle would be, and your y value is going to end up being sine. So the unit circle is really friendly to use once we have it created. The creating is just the hard part right now, so we understand it, but your x coordinate essentially is the cosine. Your y value is sine. So I could read sine and cosine and off that, and then the slope actually ends up being tangent. All right, so for our circle, a few things we kind of notice here. This middle is 0, 0. So we have 0 degrees. Up here is 90 degrees. This is 180 degrees and 270. And then when it loops back around, it's 360. So that part doesn't change. Since all the radii are 1 unit, so the radius is 1, so this would be the coordinate 1, 0, because you went from 0, 0. 90 degrees would be 0, 1. 180 is negative 1, 0, and 0, negative 1. And again, what we're going to see here is all the points are in the form of cosine of an angle, sine of an angle. So what that means is actually cosine of 0 degrees is actually 1. Sine of 0 degrees is 0. So it kind of told us some of the things that we already know. So if I want that we maybe didn't know. So cosine of 90 degrees I could see as 0. Cosine or sine of 90 degrees is 1. And same thing with cosine and sine of 180 and so forth. If I wanted to find what tangent is, tangent of theta is going to be y over x. So if I put the y value over the x value, I can find the tangents if I want to. So we'll add those at the end, but just keep that in mind. So your x value is cosine, your y value is sine. The first quadrant's always the hardest to make, but that one, the rest are kind of the same thing over and over. So this first one is 30 degrees because we're going to do our special right triangles. And again, from what we had on that other slide, we said 30 degrees. We said this was a 1, this was 1/2, this was radical 3 over 2. We then wrote down a 45 degrees. That's 1, root 2 over 2, root 2 over 2, and then the last one was 60 degrees. All right, so what happens is for 30 degrees, you can see we're going over radical 3, up 1 over root 3 over 2, up 1 over 2. And again, it's like a coordinate point. I'm going radical 3 over 2 and 1 over 2, right? So it's like I'm making it into a coordinate point. So I'm going to write root 3 over 2 and 1 over 2. So basically what that means is that cosine of 30 degrees is root 3 over 2. Sine of 30 degrees is 1 over 2, right? So I don't have to have that memorized really. I can read that off my unit circle. I'm going to do the same thing with 45 degrees. So 45, you can see if I make it into a coordinate point, we have root 2 over 2 and root 2 over 2. If I do the same thing with 45 degrees, I'm going root 2 over 2, root 2 over 2, right? Because I'm following that same length and that length. So I'm going to go ahead and write that one there. So this would be root 2 over 2, root 2 over 2. Right? And so if I want to know what and this is for 45 degrees. So if I wanted to know what cosine of 45 degrees is, the answer is root 2 over 2. If I want to know what the sine of 45 degrees is, the answer is root 2 over 2. Okay, and then the last one is 60 degrees. I'm going to erase these right here. So 60 degrees, same thing. I would have that for 60 degrees, same idea. I'm going over root 1/2 up root 3 over 2. Same thing, 1/2 root 3 over 2. So I'm going to write that as a coordinate point. And I'm going to write these angles in here too. So if the question was, what is cosine of 60 degrees, you would tell me it's 1 over 2. What is sine of 60 degrees? You would tell me root 3 over 2, right? So the y values are sine for that angle. The x values are cosine, okay? Now the nice thing is once we have that, you don't have to reinvent the wheel at all. It's really just reflecting. So for example, 30 degrees, right? You can see that if I follow the line down here, you would have really, this is, again, these kind of have even the same slope. You can see it's reflected down here. And you can also see if you reflect about the y-axis, you're going to have almost the same coordinate point on the other side, just with a negative sign for the x. So we already know that this point is going to be a negative root 3 over 2 because that's a negative x value because it's on that part of the other side. It's in quadrant 2. And this is quadrant 1, quadrant 3, and quadrant 4. And then the y value would be the same. Right. Same thing with this one here. If I take this radical 2 over radical 2, if I put it over here, I know that all the x values in here are negative, right? So it's really these same points are just getting reflected over here. So let's go ahead and do that. So this would be negative root 2 over 2, root 2 over 2, and then this would be negative 1/2, and then negative a positive root 3 over 2. Okay. If I do the same thing down here, I'm going to reflect the same points. So I see this would reflect down here, this one would reflect, and so forth. So I can reflect those about the x-axis. So except the only thing is the x and y have to be negative because it's quadrant 3, right? So negative root 3 over 2, negative 1 over 2, negative root 2 over 2, negative root 2 over 2, and then negative 1 over 2, negative or root 3 over 2. And we'll add the angles in these in a moment. And then the last one, if I go ahead and I could do it a couple ways, but again, if I reflect these downwards or if I reflect these across, same thing. And so I would get here, these are all going to be positive x values and negative y values. Okay, now the last part is just filling in the angles. So again, we're thinking about like these are really going to have all the same reference angle. But so now I know that this right here is 180. So if I went backwards and I want 30, this would be 150. If I subtracted 45 here, that would be 135. And if I subtracted 60, this would be 120. Same thing here. If I now 180, if I add 30, that would be 210. If I add 45, that would be 225. And if I add 60, that would be 240. And then in the other direction, if this is 360, if I subtract 30, that's 330. If I subtract 45, that's 315. If I subtract 60, that's 300. And so this is nice to know now, because if I was to say what is sine of 330, well, I can see my y value is -1/2. So you would say sine of 330 degrees is -1/2. Or if I was to ask what is cosine of 225, I see it's a -√2/2. So you would tell me -√2/2. If I wanted to find the tangents of these, tangent is just the slope, so the slope of these lines. So that's actually just y/x. So tangent for this first quadrant, if I do 1/2 over √3/2, these go away, and I would get √3/3. So my tangent for this, I'm going to erase these right here. I'm going to erase this right here. So our tangent, again, is y/x. So this would be √3/3 for tangent. And if you look at it, it has the same slope as this line here. And it's not a coincidence that a negative, this would also be √3/3. Right, and if I use that same concept, well, this, if I reflect it, this would be -√3/3. And it makes sense because a positive over a negative, and actually if you look, this is a negative slope, so that makes sense too. If we wanted to do that for the other slopes, we could. And again, it's just y/x. And then we would just go from there. If you have questions, make sure you are trying the U-Try problems and then asking for help during class, signing up for T-Bolt time, or getting help in the center.